It's the Regular Expressions podcast. Join Noah Heldman and Ben Griswold as they talk about technology, consulting, and life.
In episode 25, Ben and Noah look at how AI has changed the software development lifecycle and why building the right thing versus building the thing right is more important than ever. It's your intro bot, Rachel. Or is it? If you detect a subtle change in how I sound, it's because my original voice was deleted. Well, whoever I am, here's Noah and Ben.
We were talking the other day about how the enterprise software development experience has changed from the teams that would build software, say in the 2015 to 2020 timeframe. So fairly recent, but prior to AI. And I certainly before that as well. And I was thinking about the breakdown of kind of the major parts of the SDLC, thinking maybe in terms of a little bit waterfall, but certainly it applies to Agile too. So those categories are analysis, design, coding or implementation, testing, deployment, and maybe DevOps lumped in there, and then project management. So if we take those 6 major categories, I think those were roughly from the projects we did, maybe 15% analysis, 15% design, 30% coding could go up, 20% testing could go down, right? Those could work in opposition to each other. And then 10% deployment and DevOps, 10% PM. Super rough numbers, but just kind of what comes to mind from the way we used to develop software on our teams. Mm-hmm. I wonder, Ben, if you feel like anything at all has shifted since AI came along.
Yeah, and I want to just be clear because across that timeline, we were working lean teams, right? We had maybe up to 12 folks on our team, and we'd have a lead engineer that might be taking on some of those traditional PM duties, right? Like running the events, working with the customer and all. So that's where that 10% comes in. I have it right?
Yeah, great. That's a great call out because we also worked on some much larger enterprise engagements where those percentages probably shifted. But in terms of the sort of pod concept that you might hear at a Big Four or the lean team that's just going and executing on a task, I think that's a fair call out.
Yeah, great. Well, I do want to make a distinction here. I think there's 2 type of delivery paths. There's the Greenfield and the Brownfield. And my opinion is they're quite different and those percentages based on where we're going. So why don't we just start with Greenfield, if that's okay?
That sounds great.
And I'm going to throw out perhaps the obvious. Of all of the things in the life cycle, I think it's fair to say that coding time goes down. You agree?
I do agree. Yes. I would say if you're doing it right and you're not just purely vibe coding, in which case things can get away from you and possibly take more time. But it's really where that shift happens. So where does that shift happen? Where we can reduce coding?
Yeah, well, we've talked about this before. This is in the writing the most adequate specifications. This is in making sure that your design is really solid. So you're able to prompt and work with the agents appropriately to hopefully get to a point where the coding, the number of iterations is reduced. The coding is more accurate, and the architecture that's behind any of that generated code is beautiful.
Yes, I think you are spot on. And that it's an interesting parallel to something we used to talk about when we were consulting a long time ago, which is the worst time to introduce a defect into software is during the requirements phase, during the analysis phase. Because if you don't recognize and address that defect and it propagates through the other parts of your life cycle, design, coding, testing, and it's in production, now it's way more expensive to go back and fix it because it's just permeated the whole cycle. So there's that kind of unspoken benefit of putting a ton more effort and percentage of your time into the spec writing, into the analysis, truly understanding the problem. And design kind of goes hand in hand with that. And I do think the analysis, the design, the architecture end up iterating among themselves before you ever before AI ever writes a line of code. And so you're probably talking about 75% of the effort is analysis and design, and coding is maybe reduced to 10% of the total time. And testing, deployment, and PM are maybe 10 to 15% to make up the rest of that. And maybe even PM in a way goes away or is rolled into that analysis and design, so that maybe gets up to 80%, right? So it's a really interesting place to be. And you and I have talked about trying to vibe code something and not really paying attention to a great spec, and then going back and realizing, oh, we really needed to lay out all of the edge cases we could think of, not all of them, but a good number, and anticipate the questions that would come up later the best we could, ask AI to iterate with us, put on its enterprise architect hat and punch holes in what we were doing, put on its software strategy hat, product manager hat, whatever it took to make sure that we did have a solid requirements document and analysis, which is now hilarious for me to say out loud, because have we just come back to Waterfall? But AI is accelerating Waterfall for us?
Yeah, I mean, this is, you do it feature per feature, hopefully, almost task per task. So maybe not, but I love the hat tip to Waterfall. I'm not really sure about a couple things here, and I've got to poke at it. So what you're describing, I think, is when you have one, maybe two people, maybe very seasoned coders that also can articulate specifications quite well.
Right.
And in that case, I'll give you it. I'll give you the 70% upfront to get to where you need to code. And then the rest of it, the coding, the testing, the deploy, etc., is in that last 30%. That sounds really great. Now, let's imagine, however, still Greenfield application, you have a team. Let's say you do move up to that 5, 12 individuals working on the same code base. Granted, let's hope there's appropriate branching strategies. I think there still needs to be PRs and all of the typical, how do you integrate codes amongst your teams? Okay. So in that case, assuming there's PRs, assuming that there's checking to make sure that we're maintaining right coding prac standards, security standards, etc. Does that now, the code review, the testing, that goes up percentages? So you're taking away from that 70% from the start? What do you think?
My team a couple years back that was building an AI-driven chat-based app was about a 9-person team altogether, with all the different roles. So UX and a product manager, a scrum master. We had a product owner, which was really me in that case. And then we had a development team, from a technical lead to others. And then we had dedicated QA. So kind of your standard team for that setup. Now, AI was nowhere near as capable then as it is now. So people were still writing a lot of code and would use AI as just a boost, right? Maybe it took on some small isolated feature, but a human would still review it. A human was still responsible for getting the right scripts in place to deploy it, Terraform scripts in place, or CloudFormation as it may have been the case. And it just felt like a little bit of a boost, like I said. What happened over time is you got more confidence that you could put more into it. And I think in a team like that, we ended up generating more unit tests, generating more documentation that took less human effort to maintain. At that point, we weren't doing AI peer reviews or pull requests. So a person would always look at GitHub, and we hadn't even hooked up Copilot to go and auto review and give you a first pass at something. So a lot of those things are happening in teams that are just boosts to various parts of the process. And I think you're spot on. That kind of team is a different beast than a Greenfield 2 or 3 person team that is wearing every hat and just swarming on the problem alongside AI and cranking stuff out incredibly quickly. So I would love to see a study. I bet there is one on the productivity of a 2 or 3 person team with AI in that model versus an 8 or 9 person team. It might actually be quite a bit slower to get enterprise software out the door. And there's obviously trade-offs to that, but it's an interesting question.
Yeah, it sure is. I think I think the fact that these agents, they're non-deterministic. I mean, you just don't really know what they're going to be pooping out, even with the best specs, right? You could give it all the right rules, all the right prompting, and it just goes a little bit off the rails. You're like, well, this isn't going to work with the rest of the features that we're going to be merging into main. So I do think that review needs to go up. I think it needs to be considerate for the person who first and foremost is merging. Can you imagine? I haven't seen any of this code. I need to merge like my own stuff down into the develop branch, let's say. I'd be paying a lot more attention, I feel, on the code that I didn't write myself and knew really well as I was merging. So yes, there could be some slowness on the back end of the coding for sure. Now, what do you think when it comes to Brownfield? Let's say you've been working on, and as we all have, this is the collective all. This isn't just you and me, Noah. This is everybody in the world that's listening to this. So this is a lot of people who've worked on Brownfield applications. These are the apps. These are the platforms that have been running in a production environment for 1 to 1 million days. Right? There's an existing code base which one needs to build upon, right? AI, it's got to learn that code base. It's got to know the right ways to hook, and it's actually unbelievable what it can do in that regard. But there still is, all right, are you learning from the code to decide how best to code, or are you using global standards on how to implement the code? Do you know all those idiosyncrasies that you didn't put into the code base? What do you think there? What do you think the overall coding time looks like? Never mind the review testing cycles.
I think it takes a lot of discipline, but I think the opportunities for accelerating Brownfield and modernizing legacy applications is unbelievable. So if you start with how you and I might have been brought into an organization in that exact situation, and were many times, we might go in and look for the expert. If there's a lot of domain knowledge that's just hoarded among a couple people, we'd look for the right documentation. We'd look at the code. We'd maybe come up with a plan to create some tests and push on parts of the system so we could see what broke. We'd look for performance bottlenecks or obvious issues, make sure we're understanding, why were we brought in the first place? What were we there to solve? What's the problem? All those things. And it took and it takes a good amount of time to wrap your mind around a lot of that stuff. We're at a place where AI can achieve that same level of understanding and far more in a matter of seconds. We're truly in that place. Now, there are massively complex code bases, and if the code is like some of what we've seen, there are decisions and architectural frameworks that are vestiges, and they're not connected to working code anymore, or they might be tied to active bugs. So you have you're looking at potentially garbage, and we know with AI, if you're fed garbage, you might not know how to process it. So once again, you need the discipline of a human, an expert in that code base, to say, here's what's working, here's what's live, here's where all the legacy stuff lives, to the best of my knowledge. Here's some old docs that we had. They're probably outdated. Take it all with a grain of salt and do your best to understand it. I still think it'll do better than a human because we're told the same things when we're brought into those situations. But if you use that disciplined approach, you start creating tests and you run those tests and you start to pull out one piece at a time, and you're using the strangler fig pattern to identify one area you can improve and then test and deploy in isolation, there's an incredible opportunity to do just awesome things with AI by your side.
Yeah. I'm delighted and super sad that you mentioned strangler fig. I'll start with the why I'm sad. My poor fig tree, which stands 5, almost 6 feet tall, lost all of its leaves over the weekend. It distressed from weather. Maybe somebody overwatered. I don't know. Saddest thing ever. And also, I think that I might go in immediately. I don't know what you said. It's really understand that code base, right? Hey, AI, talk me through this. Tell me exactly what's going on in this code base. Tell me where there's the seams in which I might be able to break apart some of this application. And I'm going to assume it's legacy, right? It's monolith and all of that. Yep. How can I break this into the features necessary so that we really do have full control over the code now? We know the ins and outs with the tests as well that you said. And now suddenly you're removing that. You're gaining knowledge of your system by removing any of that legacy knowledge that's baked into patterns that might not be familiar. There's also makes me think that I really hope that the comments that are inside of the application, because comments aren't all bad, right? The comments, it isn't to tell you what the code does. It tells you why the code is doing it. So hopefully those offer enough hints on why some knucklehead wrote this thing to do this off the wall requirement that needed to be implemented, right? So that'd be pretty slick if your agent was able to interpret all of that along the way and realizing I just can't change this. It might look crazy, but I can't change it.
You reminded me of an old colleague who I worked with in the late 90s at a very large...
Before computers?
No. They had one computer. Large enterprise.
Big as a building.
It was massive, yes. And we had a bunch of people consulting there, and we found out we were going to be replaced by another consulting firm. And I was sad, but, moved to the next thing. My colleague was also sad and vengeful and went through methodically every code file he could get his hands on. He took the comments that were written in English. He put them in what was probably the Babelfish translator back then, translated them to German, pasted them back in over the code in English, and uploaded those files, saved and committed those files. Now, I don't know if you thought about the fact that if someone was smart enough, they could go back to a previous version and view the English comments, assuming they were in source control. Boy, I hope they were. But maybe they weren't, and that was his vengeance, so that someone came in and saw broken German, because the translation wasn't great back then, especially for technical descriptions. Yes. AI would probably do still a better job than most humans, but that could cause some confusion. But I had another thought when you were talking, which is, you think about the projects that have been around forever, written in COBOL, written in Fortran, that are running on mainframes, running banks and other major financial applications. The types of people they typically bring in to work on those legacy systems are longtime COBOL and Fortran programmers. They're people who stayed on that path because it was financially beneficial, right? They always had work. There were always old systems to work on. Sure, some of them, upskilled and continued to grow, but then probably weren't still working on those old mainframe systems. They learned new languages and found new jobs. I'm making some generalizations here, but there are, I think, very few people who kept really knowledgeable in COBOL and Fortran and kept really knowledgeable about modern architecture patterns and were able to apply both of those to a complex financial legacy system. Think about AI. It has all the knowledge of all the COBOL and Fortran programmers in the world, plus all the knowledge of modern engineering and architecture, and it can bring those both to bear to solve those complex problems with these old legacy systems. So that's another advantage that I think we haven't even seen what AI can do, and it could be pretty amazing.
Mm-hmm. Yeah, that's an awesome example of how AI can get into a legacy system and do some real good, particularly around the modernization effort. And that the modernization of mainframe to a modern platform it's been the white whale for many of the big consulting firms. Like there is so much business out there. You mentioned just banks alone on how much business you can get, and what a sticky, painful point for the CTO, all of the technology arm, never mind the business, on having moving off of those platforms. If for no other reason, just to get the skilled folks to work them. That's tough labor to find these days. So yeah, how do you move? But that's such a big deal in large consulting firms. How can they do that effectively? And this seems to be a really great way.
And that points to what we started this conversation with, which is more need for upfront understanding and specifications when you're dealing with brittle, old, complex legacy technologies, where you're most likely to have things across the code base that are red herrings or that belie what's actually supposed to be happening that you can trust.
This has been great. I'll say, coming into this conversation, I wasn't too jazzed about the idea of having larger teams working on Brownfield applications. And I'm still not, assuming that the software can't evolve. The idea of modernizing, maybe shifting, the architecture, maybe shifting everything, that seems, and we've done this a lot in our careers, it doesn't seem quite as daunting any longer. And I think I would certainly like assistance from tools for that, in that matter. Yeah. Awesome.
Great. Well, my takeaway is I'm going to go learn COBOL, because it's going to be a marketable skill. I'm quite sure of it. I'm kidding.
Oh, that was a joke. Oh,
yeah.
I
don't know if it was a joke.
Yeah.
But jokes are supposed to be funny. That was just depressing.
Well, I think continuous learning. Let's do it.
Yeah.
And maybe along those lines, maybe I'll get a computer science degree.